Welcome to ePathshala lecture series on computer science. In today's module, we will be looking at the various visual encoding principles as such. So here, some of the learning objectives of this module are: you will be introduced to the different types of visual encoding patterns. You will learn various visual encoding variables. You will also learn what marks and attributes are, and you will also come to know about the expressiveness and effectiveness of the visual that is being created. So what is visual encoding? As such, there is a saying that sameness of a visual element implies sameness of what the visual element represents. If two visual elements are same, it means to tell that whatever it represents is also going to be the same. So visual encoding is a process of encoding the images as well as the visual sensory information into a particular visual. We try to analyze a combination of marks and channels which show the abstract data dimension as such. The visual encoding is also the way in which the data is mapped into various visual structures upon which we as designers try to build the images on the screen. The amygdala is a complex structure that has an important role in visual encoding. What is this amygdala? It is a part or organ in the brain which is involved in understanding the various visual encoding patterns as such. So what is the input for visual encoding? As such, the input is, in the case of a mathematical model, we can say that it is only the raw data as well as the operations that can be performed over the data. Whereas as a conceptual model, we can tell that the input for visual encoding is some kind of semantics that is associated with the data as well as the domain knowledge about that particular data. So if you look at the entire visual encoding, as such, the input can be a mathematical model or it can be a conceptual model, as we have seen in the previous slide, and then using that and performing various tasks over the data, we try to create output images, which is nothing but using some kind of visual encoding patterns. So there are, broadly, we can classify the visual encoding into two types, that is planar type of encoding and retinal type of encoding. In the case of retinal type of encoding, the human beings are very sensitive to these kind of retinal variables. Some of the retinal variables are colors, shapes, sizes, which they easily differentiate between various, the human beings can easily differentiate between various colors, shapes, size and other kind of properties. The other type of visual encoding pattern is a planar variable. The planar variables can be applied to all kind of data types as such. So this is a mapping of data types to its encoding pattern. If it is a quantitative data, as we have seen in our previous module, like some kind of rainfall, say 20 millimeter, 50 millimeter and things like that, which represents quantitative values, we can use the position attribute, the length, angle and slope attribute and the rest of the attributes that are given here to represent this kind of quantitative data. In the case of ordinal data, where the data is in some ordered form, say for example the days of a week which are supposed to be in particular order, some of the visual encoding patterns that are associated with the data are the position, the density, the saturation, hue, texture and the other things that are given here, which can be used to represent this kind of ordinal data. In the case of nominal data, where the data is represented in the form of names or something, where it is a categorical type of data, some of the visual encoding patterns are using position, we can represent the data. We can also use hue, texture, connection, containment and things like that to represent these kind of nominal data type. So from this tabular column, it is understood that for a quantitative data type, position, length and angle are most prominent way of mapping the data to some kind of encoding patterns. For an ordinal data type, position, density, saturation, hue are the best ways of mapping these kind of ordinal data type to visual patterns. In the case of nominal data, position, hue, texture, connection, containment are best ways of mapping the data type to some kind of visual encoding patterns. So what are the various visual encoding principles? These are the Burton's, this chart is given by a person named Burton. So it is Burton's original visual variables. So they, the x and y values, they try to differentiate between x and y values, size, texture, shape, orientation, color and color value. So in the first row, it has given that position, that is change in the x and y axis values. Next one is size, which is change in, it can be, the size change can be with respect to the length, or it can be with respect to the area as shown here, or it can be some kind of repetition as shown in the, as shown here. Next one is change in shape, that is there are infinite number of shapes that are used to map different types of data set. So you can use any kind of shape to represent the data as such. Next one is values, which changes from light to darker value. Say for example here it is shown from white to black. There can be color changes, changes in hue at some given value can be represented like this, or it can be some kind of orientation wherein there are changes in the alignment of the lines. So you have different orientations of the lines as such. Next one is textures or patterns, which are variations in the grains. So these show different variations or different textures and patterns that are used to map different data variables. So this is your x and y. As we have seen in the case of retinal data, in the case of retinal and planar data is more sensitive to, human beings are more sensitive to retinal data as such, and planar data can be applied to any different kinds of data type. Here this is one kind of planar data where we use the x and the y axis. So if here x axis represents a certain value and y axis also represents certain value, and these are very good in, these kind of representation are very good in representing some kind of quantitative data. So here it is just two planar variables, data variables that we try to consider in this case. Next one is size. So in general, size also indicates greater quantity or importance. As and when the size increases, it means that it conveys more information, or it is the weight is more when compared to the other types. So in terms of quantity, area carries the value message. A square with 2 centimeter size indicates 4 times as much stuff as a square with 1 centimeter side. So here we can say that Ivy, just on looking at this visual, we can tell that Ivy has a greater population when compared to another city, Beaton. Next one is orientation. Orientation typically indicates the relative orientation or direction or flow of motion. So here, just on looking at this visual, we can clearly tell that Ivy is lying perpendicular to that of Beaton as such. The next one is color. So color is often modeled as some 3-component value. So here we have shown a representation, one form of representation, that is a HSV format, where H indicates the hue, that is the redness or the greenness of the color that it represents. S indicates the saturation or the chroma value, which will talk about the color purity, and B indicates the value or the color intensity, which talks about the lightness and darkness of the color. There are also other color models that exist, say RGB, which are particularly used in display devices, and CMYK, which is cyan, magenta, yellow and black, which is particularly used in the printing industry. And there are various other color models that are available, like HLS, which are used in various applications. But these kind of models are set by a standard, that is this CAE, which is an international standard based on physics. So we can, here is an example for color information. Many hues have particular association. The value is often used like size to indicate the quantity or importance of it. Saturation is usually often used in combination with value, but it may also be used independently to control the prominence of symbols. So here we can see that some islands are there in between lakes. Here these are some lakes in between islands. That is a kind of representation using color. Next one is the shape. The shape may be used simply to distinguish between various symbols. Say abstract, it can be an abstract symbol, or shape may also be used iconically, that is in the case of mimetic symbols. So recall that an icon is a small picture that provides a metaphor for a particular idea or process. So here are examples of symbols for abstract symbols as well as iconic symbols. Next one is a pattern. The pattern comprises of the texture, which talks about the density of the symbol, for example, which is used to communicate the relative concentrations. The pattern may also comprise of the focus, that is the crispiness of the symbol, for example, which is used to communicate the relative certainty. The pattern as such is an arrangement of symbols, for example, whether it can be in an ordered form or it can be in a random fashion. So this is an example for a texture. Here we have 3 different items with different quantity, features of quantity 3, bugs of quantity 5, and the user stories of quantity 6, which can be represented simply as a bar using different texture. So in the feature we don't apply it as just the hollow space, whereas in the bugs we have slanting lines, and in the case of user story the pattern is just dotted patterns. This is an example for texture. Next one is color as well as size can also be applied to distinguish between 3 different values. So on looking at this visual, you can see that the value for 3 is represented as a smaller circle when compared to a value for 10, which is represented as a very bigger circle. So we have and all the 3 are given by different, are represented by different colors also. The next one is shape plus value example. Here for the same example we have seen that we can represent this in a visual format using different shapes. So we have a square shape, a triangular shape, and a circular shape to represent values 3, 5 and 10. This is one good example for visual encoding variables. So here the color indicates the containment, the size indicates the number of medals that it counts, and the X and Y indicates the world map as such. So just on looking at the size, we will understand that which country has got more number of medals. So this is a chart which talks about the variable type as well as the kind of encoding pattern. Okay. So here we have the entity type, we have categorical, which can be represented as color hue. We have the priority kind of variables, which is an ordered type where we can represent it as using the color values. We have average effort in points, which is represented as a quantitative value, can be represented encoded in the x-axis, and average cycles, which is a quantitative value, which can be represented on the y-axis. The next one is a mark. A mark basically is a basic graphical element or a geometric primitive. It can be, a mark can be in the form of a point, or it can be in the form of a line, or it can be represented in the form of an area, or in the volume, or in the form of a volume as such. So these are good examples for using marks as well as attributes. So here we try to represent the length. These marks try to represent the position of a particular value. These marks represents the color. These marks shows a change in the size of the mark. So here we can see a variation in the length of the mark, the position of the mark, color of the mark, and the size of the mark as such. Channel is another one interesting visual encoding pattern. In the case of a channel, it is used to control the appearance of a particular mark. So position is used to control the appearance of a mark, size can be used, shape can be used, orientation can be used, hue or saturation and lightness can be used to control the appearance of a particular mark. So these channels can be classified into 2 types, magnitude channel and identity channels. So these are good examples for magnitude channels, which are used in ordered attributes, which will show a variation in the magnitude. So here this is position on common scale. This represents, in this example, represents position on unaligned scale. This represents a one-dimensional size, the variation in the length. This shows the variation in the tilt or angle. This shows the difference in the area. This shows the depth information. The other one is the color luminance. color saturation value, the difference in the curvature and the difference in the volumes as such. Then in the case of identity channels, we have categorical attributes like spatial regions, we have color and hue, we have motion of the values, and we have shape that tries to differentiate various data elements. So the mark type can be a point. In the case of a table, a mark is usually represented as a point. In the case of a network, a mark type is going to be a node as well as a link as such, and the link represents the connection or the relationship between the different nodes, and it will also represent the containment of the hierarchy of the various nodes. There are two principles associated with visual encoding, that is expressiveness principle, which tells about the visual encoding should express all or only the information in the dataset attributes. So if a life factor is one wherein we try to just on looking at the visual, it is not possible for us to get the correct information. It is not very expressive in nature, and it tries to give a very wrong information as such. Next one is effectiveness, that is the importance of the attribute should match the salience of the channel as such. So effectiveness is also expressed as data ink ratio. Expressiveness is expressed as life factor. So this is an example for expressiveness where the visual representation encodes all the facts. So this is an n-dimensional data set, that is an iris data set where we have different flowers with petals and sepal values which are represented like this. This cannot be simply be expressed as a single horizontal dot plot because there are multiple cases which tries to map to one single value. So it cannot be represented as such as a single dot plot like this. So if you consider the effectiveness of mappings, we can have cells in the visual areas which are differently tuned to each of the following properties, that is orientation and size with respect to the luminance, color with the two types of signals, stereoscopic depth information and motion information. So there are types of effectiveness, that is accuracy. Effectiveness also talks about discriminality. Effectiveness also talks about separability of two different data as such. So here is an example for accuracy, effectiveness, accuracy as such, the perceptual judgment versus stimulus, which shows the Weber's law S is equal to I power n. This is an discriminality. So here it is possible for me to discriminate between two different values that are by looking at the different levels of grays as such, and it is also possible for me to discriminate two values by just looking at the line width. Next one is the separability, that is it can be separable with respect to various integral channels. So using position it is possible for me to fully separate. Using size and hue we try to separate them. Using size, width and variation in the shape it is possible for us to separate, or using different colors it is possible for me to separate. Till now we have looked at the expressiveness and effectiveness of expressing a particular visual. Next we look at the elements of visual encoding attributes as such. So space is an element of visual, is considered to be an element of visual encoding attribute. Space as such is a negative or positive area that is present in an object and it occupies certain area as such. Using simple principles we can control the relative position of every element. Using white spaces it is possible for us to control the location of each and every element. Using overlapping elements we can control the position of the elements, and using values it is possible for us to control the relative position of various elements that are present in the visual as such. So here we can see the importance of white space as such. So this is an example of space usage. So here we see overlapping objects that are placed one over the other. Here we see that space is used to distinguish or separate two different planes or two different rectangles as such. This is an example of overlapping circles. This is here we can see the usage of space where it is used to represent the area between two different objects that are seen here, as well as it is the space is also used to represent the area that is filled inside this particular object. Some of the tips in using the white spaces are, we should not trap the white space in between the objects, that is, don't trap white spaces between two distinct elements as such. This may interrupt the flow of the design. We can use the space to increase the font size, the graphic size, or reposition the elements to avoid these kind of interrupts. We can keep the text cells small. Don't have text stretch across the entire length of the design so that some of the white spaces occupy certain region of the design as such. Avoid rivers, water, and river is a word space that appear near each other on subsequent lines of text. We need to edit the text instead of changing the word spacing. The rivers may also be a symptom that the line length is too short or too long. So this is an example of the usage of white space. So the first one is a good example of usage of white space, the tennis group business card, which makes the good use of white space. Whereas in the second case, we can see that the card is very too busy with so many characters and other things, where the amount of white space decreases in this case. So this, yeah, our eye really doesn't know where to look at first when we look at this kind of card. Whereas here we can see how white space is being used to distinguishingly separate each and every object that is placed in this particular card. The next element of visual encoding attribute is size. Size is how size represents how big or small the objects are in relation to the space they occupy. The primary role size plays in design are, one is a function, the other one is attractiveness, the other one is a organization. In the case of the function, for example, the age of audience can be represented using these kind of size. Older people would need typeset larger to help in reading. So we'll have older, age can be used as a function. Attractiveness, add interest by cropping or scaling the elements. We try to add interest by attracting the audience as such, by cropping or scaling the elements that are present in the design. The next one is organization. Make the important element the largest and the least important to be the smallest in the visual as such. So we need to make whichever part of the visual is supposed to be most important is shown in a bigger size when compared to the least important one, which has to be shown in the smaller size. So thereby size also acts as an element of visual encoding attribute. So these are good examples of size usage. So we have big, small is represented as smaller size, big is represented in bigger size, which tries to attract people. Just on looking at this, we can understand that people try to look at this big one first and this letter big when compared to this small as well as a letter smaller one. So first, the most attractive one is the bigger one or the size which is bigger. That is a good example of size usage. These are different examples of shapes. As we look into this particular figure, we can see different shapes are present. Some of the shapes are more attractive when compared to other shapes based on the appearance, based on the design of that particular shape, that may be, and based on the color that it applies to the foreground and the background color that has been applied to the various shapes. It may be more attractive or it may be less attractive in, this case, in that case. The next element of visual encoding attribute is a texture. Texture is the look or feel of any object or surface. The appearance is either visual or that means it can be in an illusionary fashion, or it can be tactile, that is, it may be physical to touch. So some of the examples of textures or patterns are good examples of visual texture. So here are two examples of visual texture. The first one is more illusionary in nature. The second one is more physical in nature as such. So these are good examples of textures. So we have various examples of texture, which are this kind of pattern or texture is more physical in nature when compared to these kind of textures or patterns which are more illusionary in nature as such. So these are different examples of textures. So in summary, if we see, we have looked at the various types of visual encoding techniques. we have looked at the various visual encoding variables. We have also looked at the various kinds of marks and the attributes associated with the marks. And finally, we have looked at the expressiveness and effectiveness that are applied to the visual. We also saw the various visual encoding attributes that can be applied to the visual as such. Thank you.